Imagine a time before time, a place before space. This is hard to do because our minds work in time and space. But this is the realm of the singularity. The singularity is where our universe, with all its galaxies and stars, began. It's a point so small, so dense, that it defies our normal understanding of physics. Everything we see around us, from the smallest atom to the largest galaxy, was once squeezed into this tiny point. It's hard to imagine, but the entire universe, all its matter and energy, was contained within the singularity. It's like trying to fit all the books in a library into a single dot. The singularity wasn't an object in space, it's space. It wasn't a moment in time, it's time itself. Before the singularity, there was no space, no time as we know them. It's a mind-bending concept, but that's the nature of the singularity. It's tempting to ask what came before the singularity, but that question might not make sense. It's like asking what's north of the North Pole. The singularity represents the very edge of our understanding. It's the ultimate frontier of science. In the everyday world, we have rules. We call these rules physics. Physics helps us understand how things move, how energy works, and how gravity behaves. But at the singularity, our normal rules of physics break down. They simply cannot describe the extreme conditions there. Think about a black hole. Black holes are incredibly dense objects in space. Their gravity is so strong that nothing, not even light, can escape. The singularity is even denser than a black hole. It's like a black hole taken to the extreme. At the singularity, gravity becomes incredibly strong, squeezing everything together with unimaginable force. Our current theories of gravity, like Einstein's theory of general relativity, can't fully describe what happens in such extreme conditions. To understand the singularity, we need new physics, a deeper understanding of the universe. The singularity challenges our understanding of the very fabric of the universe. Space and time, which we normally think of as fixed and unchanging, become warped and distorted near the singularity. Imagine a piece of fabric stretched tight. That's like space-time. Now imagine placing a bowling ball on the fabric. It creates a dip, a curvature. That's what massive objects do to space-time. The singularity is like an infinitely heavy object, creating an infinitely deep well in the fabric of space-time. We can't observe the singularity directly. It's hidden from our view, shrouded in the earliest moments of the universe. But we can use our understanding of physics to try and imagine what it might be like inside this mysterious realm. Imagine being inside the singularity. It's not like being in a room or even in space as we know it. There's no up or down, no left or right. Space as we understand it doesn't exist in the same way. You wouldn't see stars or galaxies because light itself behaves differently in these extreme conditions. Time, too, would lose its usual meaning. Inside the singularity, the past, present and future might be all mixed up. It's like trying to imagine a world without time, where everything happens at once. Our human minds struggle to grasp such concepts, but that's the nature of the singularity. Some theories suggest that the singularity might be a point of infinite density and temperature. Others propose that it might be a gateway to other universes or dimensions. These are just ideas, of course, but they highlight the profound mysteries surrounding the singularity. The singularity is a place that defies our everyday experience, a realm where our intuition about the universe breaks down. But even though we can't observe it directly, its existence has had a profound impact on the universe we see around us.